Alright, in this video we're going to be using Python3 and we're going to make a simple terminal-based tic-tac-toe game board. Alright, so let's get started here. I have my text editor Atom open. I need to create a new file. Let's call this tic-tac-toe. Alright. So the idea for the game of tic-tac-toe, most people are familiar with it. It's a 3x3 game board, and the players are X and O, and the goal is to get 3 in a row. All right. So when we're thinking about creating a game, we kind of want to come up with the general steps that we're going to use, the things that we're going to have to code up, and we're going to try to do those, divide it up into small pieces, and code up those pieces the simplest way we can think of at first, and then we're going to add to it. So the primary goal is to get things working first and then improve upon what we initially decided. Alright, so first we're going to need some sort of game board, alright, to store the data. So we need a game board, and we need basically game state. Okay, so the game board and the game state we're just going to use global variables for, but we could have one giant dictionary for all of this. The idea of game state is important because if you want to save the game, you need to have all of your variables associated with the game in one object or in one dictionary or something to that effect, and then you can save that to a file, and then it's as if your game is frozen and you can load up that state and resume the game whenever you want. Tic-Tac-Toe is a small enough game where we don't really need to worry about that, but most games you're going to make are going to have some sort of game state, right? So our game state is going to have a game board to start with, so we have to figure out how we want to design this game board. As I said, the game board is 3x3. It's a 3x3 grid, and we can just use a two-dimensional list for that. So if I have a board, I might make a function, create board, and then my board will be a list. And within that list, we're going to have 3 other lists. And for each space of our game board, we are going to hold a character. Okay, so with an empty game board, this is the first row, right? And then the first column of the row is the empty space, right? So in a game board, this could be an X, and maybe this could be an O, and we would go back and forth filling in this game board with different moves until we detect three in a row. Okay, so we'll undo that and go back to blank. So blank is the default. Alright, so this function create board is going to create a brand new board for us. We create this board variable, which is a two-dimensional list, and then we return the board. Okay, so this function will create a board for us. So as a general rule, when you're creating a file, a Python coding file, you want to create all of your functions at the top, and then down towards the bottom you'll have your main program area. So we're going to continuously add functions here, and then as we do, we'll add code to this main program area and test them out and make sure everything's working properly. So we're going to have a board B, and we're going to say create board, and that should give us a brand new board, and we'll print that out. Print out B. Alright, so let's test this out. Python3 and tic-tac-toe. Okay, so we do have a two-dimensional list, and each one of those items is the empty string. If we wanted to print out a particular location, let's say we wanted to print out the top left square, right? We could do that by reference by index. So we have, let's go ahead and change this variable name to board so we don't get confused. All right. So if I wanted to access just one of the individual squares, I would use reference by index. So we use our board variable, which is holding a two-dimensional list, and we access the first element of that list, which is this element, and that also happens to be a list. So then we can access the first element of that list, which would be this. Okay, so to access the items in this two-dimensional list, we reference the list itself with the board identifier, and then use reference by index, square brackets, and then an index number, and then reference by index again. Okay, so this style would be how whenever we need to access a position on our board, we would use this style. Okay, and we'll run this and make sure that that works, and that prints out a space. So to make this more realistic, we'll do something like that, and that should print out an X because that is the row 0, and this is the column 0. So next, what we need to do is think about how we're going to print out this board. Okay, so we printed out the board with just the print statement, and as you see, that looks kind of ugly, right? So we want a nice user experience, so we want to print out an actual game board. So let's make a function. Okay, print board. This is going to take in a board, so we have a parameter defined in this function signature. The parameter is board, which means when we call the function, we need to pass in a board as an argument. And for this board, basically we want to, the easiest way to do this would be to just print out each one of these. And then on a new row, print out the next 3. And then on a new row, print out the next 3. So we could use a format string. A format string allows us to inject a Python expression defined inside of the curly brackets, and it will automatically convert it to a string. So I can reference board 0. Yeah, the linter doesn't like that. Board 0, 0, and then board 0, 1, board 0, 2. Okay, so these curly brackets are just Python expressions that allows Python to calculate the value inside of the curly brackets, and it injects that value into our format string, right? And it automatically converts it to a string for us by way of the str function. An alternative way we could write this, it's a little more verbose, would be print right? And this isn't that much more verbose right now, but eventually we're going to add an actual grid pattern, the classic tic-tac-toe hash table, right? But right now we're just printing out each of the positions. So as we see, board is our board variable that's going to be passed in, right? And we're accessing the row 0, which is that row, and then item 0 here, row 0, item 1, and then row 0, item or column at index 2. Right? So these two lines are essentially the same, but we're going to stick with the format string. And what we want to do, this is just going to print out the top, and so we need 3 more of these, right? We need the middle row. So in each one of these, we will make that the index of the middle row, right? Because that's index 1 for the larger game board. And then of that item, we have index 0, which is this space, index 1, which would be the center square, and index 2, which would be that item. All right, and then one more, and again we will increment the row. All right, so this is a very, very simple way of printing the board. It's not very nice, right? So we can print the board, but this allows us to verify that we do have a tic-tac-toe kind of board, and we can print that out. Right, and so we see 1, 2, 3, 1, 2, 3, 1, 2, 3. We do have sort of game board, but when nothing's when no one has moved, it's not obvious that these are empty spaces. It's not obvious what we're printing out here, right? So we want a nice user experience, so we need to clean this up a little bit. We need that kind of classic tic-tac-toe hash game board, right? So if we go back to our print board function, we can make this a little bit prettier. We can add a space there, space, pipe, space, space, pipe, space. Right, add a space at the end. And then down here, we can add hyphen, 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 pipe, hyphen, 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 pipe, hyphen, hyphen, hyphen. All right. And so this is this pipe is going to line up with this pipe, and we have 3 characters here, the hyphens, that are meant to represent sort of that horizontal line look. And we have a space there, one of our characters from our game board, and then a space. So there's 3 characters up here, and then a pipe. 3 characters up here, and then a pipe. So that's what we're doing down here. We have 3 characters, hyphens, and then a pipe. Right? And so we'll do that between each one of our rows, and then on each row we do the space, space, pipe, space, space, pipe, space, and space at the end, space, space, pipe, space, space, pipe, space. Right? And we'll see what this looks, and we can make modifications if we need to. Okay, so that looks pretty good. And we see this kind of, tic-tac-toe board. This is kind of what we're used to seeing when we play tic-tac-toe. We might want to replace these with a plus sign, so there's continuity between the horizontal lines and the vertical lines. So if we put a plus sign here, you get both the vertical and horizontal element there. So let's try that. We'll change these here to the plus sign. And this is just all about taste. It's whatever you prefer. Alright, so the plus sign there has the vertical continuation and the horizontal. Honestly, I think it kind of looks better with the pipe. Let's go back to the pipe. Alright, so we can hit Control Z a few times and undo those changes. Save our game. The pipe looks a little bit better there. Alright, so now we've printed out a fairly good looking board, and we pass in the board here. We created our board. This was a brand new board, and then we passed in that board as an argument when we called the print board function, and we define the board parameter. So when we call the function, whatever argument data is passed in, the parameter then holds that data. Right? So when we reference board here, that is whatever was passed in when the function was called. Alright, so that's good. Let's go back to an empty board when we create our board, because that's the default behavior. Alright, so we have this print board function. Well, what else do we need? Well, we need some concept of getting a user position. Right, so we might we need some way for the user to be able to specify where they want to move. Right, they want to move in one of these squares. So one way we could do it would be to get an index value for the X and Y position. right? So this would be 0, 0, 0, 1, 0, 2, kind of a coordinate system that's top left to bottom right. So to do that, we would use the input function, but then we would want to convert that to integers, right? And use those integers as the indices of our two-dimensional list. But most users aren't familiar with starting the numbering at 0, so we'd probably want to ask them for a number between 1 and 3, and then subtract 1, so we can use it as an index. And we would have to ask for 2 pieces of data. So right away, that seems like it's getting a little bit complicated for our needs. 2 pieces of data. We have to have an index number offset by 1. So maybe there's a simpler way we can do this. Maybe we can just consider that to be square 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we could have a nice help menu to explain that, but we're gonna skip that for now. So again, the point when you're developing something is you want to kind of get things working, and then kind of improve upon them, right? You want to get a base idea down that's functional, and then improve on any of the steps that you use to initially build the program. All right, so let's look at getting user data, or a user move function. User move. All right, so we're going to define this function, and basically with this function we're going to pass in a board, and what we want to do is we want to collect a position from the user and then make a move using that position. So we also need to know what player, whose turn it is, right? Because if we are going to make the user move, we need to know what character that we want to mark the board with. Okay, so we have to decide how are we going to represent a player in this. Well, for our purposes, the simplest way to represent a player is just with a character X or O, right? In most games, a player will probably be more complex than that, but for at least the initial way we're going about this, a player can just be the character X or the character O. All right, so what we want to do is we want to get from the user a position, right? So the move is whatever the user types here, and we're going to say enter your move 1 through 9. Okay, so we're telling the user to type in the number 1 to 9, and that will represent the position. So we're going to have a big if-else statement at some point. And if they type in a 1, then we would fill in the player, whatever player character we got here, we would fill in that position. If they type in a 2, whatever player character we get in this function will fill in that position. All right, so we have our move, and we can say if move is the character 1, because remember, everything we get back from the input function is a string. Okay. So if our move is the 1 character, we're going to look in our board, and that is the item at 0, 0, and we're going to set that equal to whatever player was passed in. So player could be an X or it could be an O, we don't know. Whenever we call this function, we're going to pass in whoever's player, the player of whoever's turn it is, right? So if move equals 1, board 0, 0 equals player. Now notice the difference between the double equals. This is a comparison. We're checking to see if these two things are equal. If they are, this returns true. This is an expression that returns true. If they are not equal, this returns false. So if this condition is true, we execute the indented code block. If it's not, we move on to the unindented level, unless there is an elif, which is still at the unindented level, but now we're going to check another condition. So here, if move equals 2, we're going to do something similar. That means the board at row 0, position column 1, we're going to set that equal to player. Right? Now again, this is not the most efficient way to code this up, but as you're creating a program, a lot of times what you want to do is put down the simplest thing you can think of that will work, and like I said, get the program working. And then once you get things working, then we can look to see how we can improve. What do we want to change to make this better? What are the efficiency gains we can get from different implementations? All right. So lf move equals 4, and so as you can see, this is going to just be one big if-elif statement. We're going to go all the way up to 9. So we can use copy and paste to our advantage here. Copy, paste, and I will unindent and make sure we change this one to an elif, and this will be 4, 5, 6. And the only difference between these three from the first three is that the row has changed. So the row goes up by 1. Right, and then we can use copy and paste again. Control C to copy, Control V to paste, and so case 6, case 7, case 8, case 9, and the only difference between these three is that our row has increased by 1. Alright, and then we can have one final statement, and we can say I'll have a format string, invalid move, and then use our curly brackets. Move. And maybe say error. Right, may or may not be considered an error, but we'll just start that way and we can change it as we go. Alright, so we're going to try user move. So down here in our main program area, this is where we use all of the functions we've been creating up here. In our main program area, we have created a board. We know that we can print out that board. We know we can access individual items using reference by index like that. We don't really need this line. We need a concept of a player, and we know that the player starts out as the X character. Right? So we have a board, we have a player, we print the board, and then we can say user move, and we're going to pass in our board and our player. Right? So we print out the empty board. This should be create board. It should be a two-dimensional list that starts out empty. Right? All of the characters are empty. And we set a player equal to X. We print the board that's empty. We provide the board argument and the player argument to user move when we call the function. So we ask the user to type in a move, and then if move is 1, we set that board square equal to that player character. Alright, and just to make sure this is working, we will print the board out again. So I just duplicated that line, print board, and then I moved it down. So we print the board, user move, and we'll test this out. Alright, so we have the empty board. Well, let's move at position 1. And we see the X fills in. Let's run the program again, and let's move at position 5. Okay, that's the middle. That looks good. Position 9. Right. Alright, so that's looking pretty good. Let's say that we wanted to use the next player character, right? So the idea is we need to alternate between players, and so we would change the player, move again, and print the board. Change the player, move again, print the board. Alright, so this kind of pattern develops. Change the player, make a move, print the board. Alright, so we see this code occurring over and over with only one small difference, right? And that's a change in the player. Whenever you see this type of repeating pattern, there's usually a better way to implement this, right? In this case, a loop seems like it might make sense. We do this repeatedly until we have a winning condition. All right, but first let's just test this out and see if we've kind of got a sense of this working, right? So let's move at position 2. Print board. Oh. We need to print the initial board and then move and then print the board. There we go. So the first board print is right after you create the board. That's empty. And then player is X, move, and print board. So I left off that print board there. So I'm going to hit Control-C to end the program and start it over. Alright, so it's empty to start with. I'm going to go at position 2. And now I'm going to go position 3 for O, and then position 5 for X, and then position 6 for O, right? And then the program has stopped because I'm no longer calling user move, right? Another issue with this that we're going to kind of ignore initially is if I go position 2 for X and then position 2 for O, we can stop over the moves, which really what we want to do is check to make sure that the position hasn't been taken, and then only if it hasn't been taken do we move there. Okay, so but we'll get to that later. So like I said, initially you want to just get the most basic functionality working in a particular program, and then work to improve it and make it a better user experience. Alright, so as we said before, this is kind of a game loop, right? A loop looks like the thing we're going to use because it's the exact same 3 lines of code, and it's just repeating over and over. So that's an indicator that we probably want some sort of loop. And most games will have a game loop. It's something that some condition or some series of code that executes over and over and over until there is a game ending condition. Usually that is like a timer runs out, or somebody wins the game, or somebody quits the game. So you have some sort of game ending condition that will end the loop, and then inside the loop the game just runs. There's code that runs over and over, and that's very common in any game. So we're going to call this the game loop. I'm going to put a little comment in here. And like I said, it's just a loop that runs, and then you have some condition in which the game runs. So basically you want to think about when do we want this game to end? When do we want the looping to stop? Well, we probably need a winner. And we're going to start the winner off as none. Okay, we have this winner variable, and whenever we detect a winner, we're going to set that player's character equal to, or we're going to set this variable equal to that player's character. All right. So at some point we're going to have some function that tries to detect the winner. Okay. So the condition of the game loop is going to be while winner does not equal none. Okay. So this means as soon as we set a character in this variable, as soon as we set this variable equal to one of the characters, the implication is that character has won the game. So here, winner initially is none. Sorry, as long as winner equals none. So if none is equal to none, which starts out true, then we enter the game loop, the indented area of the code. Right? So we have to change kind of this repeated code that we have down here. So we don't need all of the repeats. And we want to indent this. Okay, so as long as winner is none, we keep repeating until at some point we're going to change winner. We're going to check for a winner down here. Right. All right, so this is sort of the initial idea, and we can test this out. This is going to be a loop that repeats over and over. We're only using player X, so every time we move, player is going to be X, so that's something we're going to need to fix, right? But we move, print the board, player X, move, print the board, player X, move, print the board, and eventually we're going to need to check for winner at some point so this loop will exit. All right, so 5, 6, 1, 2, 7. All right, so this is good. This gives us the ability in a few lines of code to repeatedly execute something that we need for every single turn, right? And we don't have to add 9 different repetitions of this code, right? So that's exactly a use case for the while loop. All right, so let's start out with player X. Okay, we'll start with that up here. So that's the initial player. We can remove this from down here. So when we think about what we need to do in this game loop, right? We initially printed our board, but every single time we need to move. So this will be, I guess, user move or player move, right? So the player moves, then we need to print the board, right? Down at some point we're going to need to check for a winner, and then switch player, right? So there's kind of 4 steps here, and we're outlining them with comments. So one thing we need to do here is switch player. We can do that pretty easily. We don't need a separate function for that. So how could I switch a player? Well, the player options are the letter X and the letter O. So we can use a simple toggle pattern for that. First, we can check to see what player is. If player is the X character, then we need to switch it to the O, right? So again, we have double equals, that's checking for equality, as opposed to single equals, which is the assignment operator. So if the player is currently X, we're going to change player to O. And otherwise, the only 2 options here are X and O, so we don't really need another if statement there, or an elif rather. We will just say player equals X. So what this does, this is a classic toggle pattern. And it checks a variable. If it's one thing, it switches it to the other. And if it's the other thing, it switches it to the first value. So it can only be 2 things. You can toggle on or off, right? So toggle patterns are either, they're one of 2 things. A variable can be one of 2 things, and if it's the first one, you toggle it to the other one. If it's the other one, you toggle it to the first one. Okay, so this is really common, simple little pattern, a few lines of code. All right, but what this will do is within our game loop, player alternates from X to O. So when we move, the first time, player is X, so it'll put an X on the board. Second time through the loop, we will have switched to O, and player will be O, and so we'll place an O on the board. And we'll test that out now. So in that program with Control-C, whenever you have an infinite loop like this, we have not specified any way for the winner variable to not be none, so this is an infinite loop. So it's important to know how to exit the infinite loop. It's Control-C will break you out of that loop. All right, Python 3, 5, 2, and see that's good. We have an O there, and then I want to block that move at 9, and then X can go 6, and I'd want to block that at 4. Right, so it looks like this is working. But again, we've got some of the details to work out. Like we can stomp over each other's move. If X doesn't like that I blocked that, they can just go the same location and stomp over it. Right, so that's something we need to fix, but we're not going to worry about that immediately. We're just going to assume people are only going to move in empty squares. Now, one of the problems here you see is if we keep going, eventually we have this scenario, and then it continues to ask us to move, right, which is not ideal, right? At this point, this should also be an ending condition, right, where no one has won. All right, so we need to check for a winner. So this is the last kind of step. We outline the different steps that need to take place in our game loop, and check for winner is one of them. So at some point here, we're going to need to set the winner variable equal to something. So we need some function probably that is check for winner. And we're going to pass in our game board. All right. So checking for the winner, we need to create that function up here because we don't have it. So define check for winner. It takes a parameter. It has a parameter board. And there are lots of ways we could check for a winner. All right, so the maybe the most obvious one that might come to mind is to, in a particular game board, we would check to see if all of the characters in a row are the same. So we would want to check to see if these are all X's. We would want to check to see if these are all X's. Those are all X's, so that would be 3 to check the individual rows, and then we would want to check the columns to see if they were X's. So there would be 3 columns to check, right? And each column, we would have 3 conditional Boolean expressions to evaluate, right? We check to see if that board location is equal to our player, and that board location is equal to our player, and that board location is equal to our player, right? So there's 3 separate equality checks for each row or column. So 3 rows and 3 columns, and this is just for X, and then you have the 2 diagonals. So there would be 8 different checks. Each of those checks has 3 Boolean conditions, right? And that's just for X. Then we would check for O, right? So that would be 18 total rows to check, and each one of those has 3 checks within it. That's getting kind of big. So it could be inefficient, right? So one thing we can do is, if we code this right, we only ever need to check for a winner for the player who just went, right? So if I'm checking this row, if X is the one who just went, or here I'm checking this row, if X is the one who just went, I don't need to check to see if O has won, right? Assuming that the rest of my game is coded up properly, there's no way O could win, right, if X just went, just by the rules of the game, right? So that saves me right away half of the different checks that I would need to look for. If there's anything else intelligent you could do, sure there is. Depending on where you go, you only really need to check the rows or columns or diagonals associated with this square, right? So the square in the middle, I would need to check the middle rows, or the middle row, the middle column, and then the 2 diagonals. So that'd be 4 checks. If I have an edge piece that's not a corner piece, right, I would need to check the column and the row. If I have a corner piece, I would need to check column, row, and a diagonal. So that would probably be the optimal, efficient method of checking. And where was the last position? And then you would always check the row and the column. And then if it is the middle piece, you check both diagonals. If it's one of these two corners, you check this diagonal, and if it's one of these two corners, you check the other diagonal. Okay, so that's probably the most efficient way as far as no wasted compute cycles. But probably the simplest way to initially code it would just be checking for the player who just went, and we'll go ahead and check all the rows, all the columns, and all the diagonals. And that'll be the easiest way to code it up to start with, to make sure it works. And then once we get that working, we could potentially go back and try to make it more efficient. So this is a common strategy in computer science. What's the problem? What's the easiest, dumbest, simplest way to solve the problem, simplest way to code the problem, right? And then once you get it working, incrementally improve on your solution. All right, so check for winner here. We need to know, we have the board that we're going to check for, but we also need to know the player that just went. Okay, so the player who just moved, player, we're going to pass that in. Now notice here that we're checking for winner before we switch the player. That's important because otherwise player would be the next player turn, right? So if player was X, player would have switched to O. So it's important that we do this check before we switch that player, right? So we're passing in the player who just moved, and we're going to check to see if they have won. All right, so check for winner. We have a board parameter and a player parameter, and what we want to do here is check the rows to start with. So check rows, and that's going to be a big if statement. So if board 0 0 equals player, and board 0 1 equals player, and board 0 2 equals player. Okay, so if all three of these conditions are true, remember with the AND operator, it's only true if both conditions are true. So this AND operator is working on this expression, which evaluates to either true or false, and this expression, which evaluates to either true or false. So if both of these are true, this entire expression becomes true. And we have another AND operator that will be working on this expression and this expression. So these two would have to be true, and also this third one has to be true. So this is effectively saying, if we go back at our board, if this is an X, and also this is an X, and also this is an X, then that's a win, right? So if that's the case, check for winner will return the winner, right? And so we'll return player as the winner, right? So if player is X, we're going to check to see if the top row is a winner, and if so, we're going to return that player. Now if it's not true, the default behavior of a function is to return none, right? So if this isn't true, we don't really even need to type this line, because that's the default the default behavior. The function in Python will return none if something else is not returned. So if this is not true, we will not execute this code block, which means we'll go back to the unindented level here, but there's no more code in this code block, so the function will return. And by default, if you don't have a return value, it will return none. All right, so again, leaving this blank or not is effectively returning none here. All right, so let's just test this out before we go through and do all the rows, all the columns, and all the diagonals. All right, so we want to check for the winner, and we're testing the top row here. So that's what we're going to do when we run this program. We're going to have the winner set by this check for winner function, right? And so first time through the loop, we'll put X here, then O, then X, then O, then X, and eventually All three will be x's, so all three of these will be true and will return that value. Then winner will have a value, so winner will be x, and in our while loop, this only runs when winner is equal to none. Once this is x, does x equal none? No. That becomes false, and we break out of our game loop. Right? So here then we can say, we'll print let's say player has won the game. Right, and we'll put this in quotes or something. Go. And so actually we don't want player here because that's actually going to be the next player. We want the winner. Right, player winner has won the game. Right, because we're checking for a winner with the player who just went. Right, but then we change the player getting ready for the next loop. Right, so we have to make sure we use winner here instead of player. All right, let's test it out. And remember, we've only implemented this first row, so we'll see if that works. All right, so position 1, and then 4, 2, and then 5, and then 3. Right? So it prints out the board. We see that there's a victory, and then it says player X has won the game. All right. So that's pretty nice. We just need the remaining winning conditions, right? So if we check for rows, I can copy and paste. And the only difference here will be, instead of checking row 0, I'm going to check row 1 on all three of these. Now notice here also that I don't need an elif statement. A lot of times in a big if-elif type condition, you would want the elif statement here, but the reason I don't need an elif is because I'm returning from the function. So if this is true, I'm returning from the function, and the function stops its execution, so it doesn't matter what else is down here. When the function stops, nothing else matters. So that's why I don't need an elif, because I don't need to continue with anything, because I found what I wanted and I returned from the function. Right? So all of these, they're just going to be if statements. And again, this is not the most efficient way, but it's a simple way to code it. It makes sense. So we would copy and paste again, and this would be the third row, right? Index 2. Right? Index 0 is this first row. Index 1 will be the second row, and index 2 is the third row. So the numbering starts at 0. All right, so that's rows. Then we can kind of check columns. All right, we'll start with one of these. So to check for the column, we want to start at 0, 0. Right? Row 0, column 0, but then we want row 1, column 0, and then row 2, column 0. So it starts out at 0, 0, then we want row 1, column 0, and then row 2, column 0. All right, so that will be the first column. Let's see if we can copy and paste that. The only difference here is that the column changes. Instead of the 0 column, it's the 1. Right? So it's still row 0, column 1, row 1, column 1, row 2, column 1. And then we can copy and paste. Same thing, the only thing that's different is the column. So that should check for columns. Then the last thing we need is check diagonals. So the diagonals are a little bit different. We don't have this on columns or rows. We don't have this consistency here. So with columns, we see, the first argument we have all zeros here, because that's row 0, and then we're checking row 2 at the different columns, and then the third row at the different columns, right? Similarly over here, check rows, you have this kind of consistency. We're not going to have that. So there's 2 diagonals, and we just have to think about what those 2 diagonals are. So the first diagonal is 0, 0. And then the middle board piece is 1, 1. And then the bottom right board piece would be 2, 2. Okay, so we do see that there is a kind of consistency, but it's different than we've seen in the check rows or check columns, right? There is a pattern, right? In this case, it's the diagonal from top left, middle to bottom right. And the pattern is the index values are the same. Right, so in that case, we would return player. And then the other case, we can copy and paste and just change the index values. This case would be going from the top right, so that would be 0, 2, 1, 1, and then 2, 1, or 2, 0. Right, so let's do that again. Row 0, column 2, so 0, 2, 1, 1, and then row 2, column 0. All right, so that's 0, 2, 1, 1, and then 2, 0. All right, so that should get our diagonals, our rows, our columns, and our diagonals, and that should be it for check for winner. And so we can run this program, and we can say, let's try a diagonal. We'll say 3, 2, 5, 6, X has won the game. Let's try that again. So we've got an error here somewhere. We did 2, 3, 5, 6. Is that what I did last time? 3, 2, 5. Oh, yeah, 3, 2, 5. Okay. 3, which is the top right square. We're going to go 2, and then 5. Right, and so we have an error here. We only have 2 items. Oh, this last condition, I'm not setting this equal to player. So that was just basically saying if that item exists. So there is always a character there, and so that expression by itself is true. We can test that with Python. So if I have a character C equal to single space, what's the Boolean version of that? True. The only way that's false is if C is the empty string, right? No characters. this does have a character. It is the space, right? So the Boolean version of the empty string is false. So this last statement, because there's always an empty string at minimum in this location, because I forgot to add the double equals to player, right? That was always true. So as soon as what happened was this one became true when I would put an X there, then I put an X in the middle square, and this last thing was always true because I wasn't comparing it to equals, so the game was ending right away. Alright, so that I just left off that little equals spot. But that's why you test after you code something up, right? Alright, so we exit out, and we can try to run it again, and this will be 3, 2, 5, 6, and then 7. X has won the game. And we could try to make sure it works with O. Say 2, 1, 6, 5, and then 7, 9. Player O has won the game. Okay, so this idea is really common in games. You have the idea of your state, your game state. You have some method of printing the board. We're just using the terminal here to print the board, but if you're using a graphical application like Turtle Graphics or any number of different graphical applications, print board would just print using that graphical technique, right? So the only graphics we have available, the simplest way to do this by default is with the terminal, but all you would need to do is print a different game board using graphics, and you would have a graphical tic-tac-toe game. Right? So you have game state, you have a way of displaying the game state, right? Print the board. You have a method of getting a move from the user, right? That could be mouse clicks or them filling in a field. For us, we're just using the terminal. And then check for winner. It's a way to determine, you know, if the game is over, right? And then you have a game loop, and all games are going to have this game loop, right? The loop will run until there's some sort of ending condition, and in this case, the ending condition is winner equals none. So there's one final condition we need to code up here, and that is if it's a tie, right? So winner will be cat. So we need to check for winner, and we want to say if there are no more player moves, right? Basically, if all of these board squares are not blank, right, then it's a cat. So we could test that with board. We'll just start with the row ones, but this is going to be one big if statement. And again, this is not the most elegant way to do this, but it's a simple way. So if board equals player, board 0, and we want to check to see that it does not equal the empty string, and then the next item does not equal the empty string, and the next square does not equal the empty string. Not the empty string, the one space character, right? Because that's what we start with. So as long as it doesn't equal, you know, the one single space character, then that means there's an X or an O there, right? So that's the first row, and then I would end that with the next row. So here we can copy and paste, and we will change the row from 0 to 1 on all of these. And then paste again and change the row from 0 to 2. Okay, so this last one is a very large Boolean expression. So if square 1 does not equal the empty string, square 2 does not equal the empty string, 3, 4, 5, 6, 7, 8, 9, if they all do not equal the empty string, then we're going to say the winner is cat, which is a tie. All right, so we would have returned the player if any of the players had won up to this point, right? If a player went and there's no other moves, we're going to return cat. So we will have changed winner. It's not going to equal X or O. It's going to equal cat. So we can check here to say if winner equals cat, print tie game, and then otherwise we'll print out the winner. All right, and we could test this. One last thing to test. Let's see, X needs to go 8. O needs to go 9, and then 7. Tie game. Right? So we now have all the conditions of a game. There are a lot of things we might want to clean up, right? We might give some instructions, what the 1 through 9 means, right? It's the squares 1 through 9. We might want to clean it up so we can't stomp over other players who are already moved, so we'd want some sort of check in here to do that. Well, all of this can be cleaned up pretty easily. There's lots of things we can do to add functionality, to add niceties, but this is the general setup of Tic-Tac-Toe. And efficiencies, check for winner. Remember we talked about you only ever have to check for a winner for a given player, and you only need to check, like if I move here, there's only this row and this column I need to check, and that would be more efficient. But this still works. Okay, so you can look at this and play with this and add some improvements.